All right, it's time. Welcome back to everybody. We do have our next test a week from today, and I thought it might be helpful if I made up some kind of a little review sheet, and I might as well give it to you now since I made it this morning. So that's what I got here. This is just a bunch of practice problems from each of the sections. You know, the first test was on the list, it was number 1 through 10, and the next one is going to go up to 20. So here's some practice. I think the best way to do better is just to make sure you actually know how to do all the problems. A lot of people on the first test, like for some of the questions, they just didn't write anything or wrote something like, I have no idea how to do this, which I'm sympathetic. But there's no surprises on this test. If you see a question on the test and you're like, whoa, I have no idea what that is, I would say that's on you, bro. I think it doesn't mean you're going to know how to do them all necessarily, but I hope that you didn't feel like there were any big surprises on the first test.
Any way that you can check our answers?
Yes, so what I'm giving you now has no answers in it, but I am going to post a PDF of this on the class website, and in that one, it will have answers at the end. So I would suggest you try and do these as much as you can yourself, and use, when you're ready, you can check your answers with the one that I'm going to post. I am just going to write the answers. I'm not going to write full solutions to the questions. So if the answer is not helpful, and you still don't know how to do it, let me know, and I'd be happy to chat about it with you. One little thing I realized this as I was typing up the answers. In number 2 there, there's a typo there. Sorry, I think there's not a typo there. Now that I'm looking at it, I don't want to change. I had suggested that I need to change. I think it's fine the way it is. Sorry, I might change my mind. I will email you all about that later on if I change my mind. Everybody got one, right? All right, great. So I hope that those are helpful. Check them out. I think it should, at the very least, if you don't know what to do to study, I say do all those problems. Remember, if you got it right on the first test, you don't have to do that one again, so you can forget about the ones that you already got, but try them out. I hope that that's helpful. Anybody got questions about that or about the test in general? I think we're going to go up to number 20 on the checklist, which we haven't covered yet, but might as well. We're going to do it next time, or maybe this time. All right, great. We will have homework due over the weekend as usual, which I also posted this morning, so you can check that out too. We were beginning last time to talk about increasing and decreasing functions. I mean, if I give you a function, can you tell me when that function is increasing and when it's decreasing? And this is not, I would say not especially hard to do, but it's a bit of a process. It'll take you a while to work this out. I did 2 examples last time. I got one now just to refresh our memory, and then I have one for you all to try. So let's try this one. X cubed minus 3x squared. And the typical question or problem for things like this. Everything all right?
Oh, yeah.
Good. Okay. The typical question is, give me intervals of x values where this function is increasing and decreasing. So give intervals of x values where it's increasing and decreasing. All right? And there's a bit of a procedure for that. I tried to outline the steps last time. There's basically 2 steps. The first step is find the critical numbers, and those are the x values which make the derivative equal 0. So that's what we're going to do first. This involves, of course, first finding the derivative. Can somebody shout it out here? What's the derivative in this case? Yes.
3x squared minus 6x.
Uh-huh. Excellent. I would encourage you, I know some people are just sort of haters when it comes to writing stuff down, but make sure that when you write this out, I think for your own benefit, you want to be clear about what's the difference between f of x and f prime of x. Those are two different things. They're two different functions. I am dismayed sometimes when I see people write it like this. I'm sure none of you would ever write this, but like that. I don't know, did you just write that? This is not really accurate. If you write it this way, what you're saying is f of x equals that and that equals that. But these are not equal. They're two different things. One is f of x, the first one, and this is f prime of x, and it's not the same as f of x. They're different. Why I'm making a big deal out of this is because much later on in this problem, towards the end, you have to plug numbers into f prime of x, which is this function. You may be confused if you don't have it sort of clearly indicated. You do not want to plug numbers into this function later on in this problem. Anyway, that's my f prime of x. And for reasons which become apparent in a few moments, it will be most convenient if I factor this in, as much as possible. So factor. From this one here, I can factor out 3x from both of those terms. If I factor out 3x, dividing 3x squared, when you pull out 3x, what remains is just x, minus, and then 6x here. If I take out 3x, what's left over is just 2. So it's like so. This is the fully factored version. Sometimes they're harder to factor, but this one was a bit of an easy one. All right, so that is f prime of x. I'm going to put this sort of in a little box there. It will come up throughout the rest of the problem. All right, anyway, that's the derivative. My goal in this part of the problem is to find the critical numbers. These are when f prime of x equals 0. Actually, can I give you a little preview? Or f prime of x does not exist. This doesn't come up in this problem, but if you look on the checklist, you see increasing and decreasing functions. That's number 19. Increasing and decreasing for polynomials, which is what we're doing now. Number 20 is increasing, decreasing, parentheses, harder. And those ones involve things which are not just polynomials. And for those, you actually have to also consider the derivative not existing, which is not possible for polynomials. Anyway, we only need to consider on the derivative equaling 0 in a problem like this. But what does that look like? So I just take the derivative and set it equal to 0, and then solve for x. Now, ordinarily, to solve for x, you would have to factor here, but I already factored it. So since it is factored already, we can just do what you would do next when it's factored and equal to 0. That means you set each of the factors separately equal to 0. So this, I say 3x equals 0, and also x minus 2 equals 0. And then each of those I solve to get two different answers in this problem. So 3x equals 0 is divide 3, you get x equals 0. And then x minus 2 equals 0, you get x equal 2. These are the two critical numbers. The critical numbers. And then, so this was kind of, as I described it last time, the first step of this problem is taking the derivative and finding the critical numbers. We have found the critical numbers. They are 0 and 2. The next big step is make that little chart of the signs of the derivatives, be they positive or negative. And that will tell you if it's increasing or decreasing. So I'm going to make this little chart here of the x values. I indicate my two critical numbers on the chart. They are 0 and 2. And you better put them in like the ordinary numerical order. This is supposed to represent a number line here. All right, and then f prime, I'm interested in the signs. It's 0 here and here, because those are the critical numbers, and that's how we figured those out, was by setting the derivative equal to 0. What about the in-betweens? That's the question. I want the signs in these. There are 3 regions to check, right? Over here, in the middle, and over here. And for each of those 3 areas, I'm going to choose my favorite number. So on the left side, I will choose my favorite number less than 0. How about -1? And I'm going to plug that into the derivative. Somewhere up there I wrote the derivative. I'll copy it down here just so we got it. This is what we are plugging into in this step. Like I said before, don't get it twisted with the original function. You shouldn't be plugging into the original function, just the derivative. So f prime of -1, that looks like 3 times -1 times -1 minus 2. I'm plugging into the derivative there. Now this you can try and actually add and multiply everything up, but it's not typically necessary to do that because all I care about are the signs, and each of those 3 factors there has a sign. The 3 is positive, the -1 is negative, and -1 minus 2 is -3, which is negative. So what I have here is a positive times a negative times a negative, and that all makes positive. So in that region of the chart, it's positive. And then we do that same thing for the 2 other regions. What number should I choose between 0 and 2? 1. Yes, I agree. So I'm going to do f prime of 1. You should always choose the most convenient number in each of those ranges. I like 0, but actually in this problem you can't choose 0 because it's one of the critical numbers. Anyway, 3 times 1 minus 2. Again, I'm plugging into the derivative, which is in the box over there. This is positive, positive, negative. So the answer here is negative. So it's negative in the middle. And then a number greater than 2, let's pick 3. I go f prime of 3. This will be 3 times 3 minus 2. That's positive, positive, and positive. So over here is positive. All right, and we're basically done at this point. You just have to sort of summarize, say the answer. The answer is there are 3 intervals there. It's increasing the first one, decreasing the middle, and then increasing again. I'll see if I can write this down. It's increasing on the one on the left is negative infinity to 0, and also the one on the right is 2 to infinity, right? And that's increasing, and then it's decreasing in the middle there, which is 0 to 2. Sorry, I had to scroll there. Decreasing on 0 to 2. There you go. That only took about 10 minutes. Now, if you're doing one like this, it probably won't take you 10 minutes because I was explaining every little thing. If you know what you're doing, you can probably do this in just a few minutes. This I consider to be an easy one. There are harder ones than that. Anybody got questions about that, though? I have one for you all to try. Then you'll find out if you have questions or not. How about you try this here? 2x cubed plus 3x squared minus 12x plus 1. And your same job. Give me intervals where this function is increasing or decreasing. I'll try and I can't really scroll it so that you can see everything I just did. You should start by taking the derivative and factoring as much as you can. That's how we began last time. Feel free to chat with your friends about it. Do you want me to close the window here?
Oh no, we were just
All right. Yeah, I mean, you can see that one. Does anyone want me to close the shade? I can. All right. Mhm.
Oh, yeah.
You all right? Okay. This- how's it going? This one you got this. Okay? Yeah. Yes. Good idea. How's it going? Yes. Yeah, the 6, so it's also right, 6 equals 0, try to solve that. Doing okay?
Yeah.
That's good. Yeah, I mean, it doesn't really matter. Even if you solve the 6 or 7, that doesn't
Oh, yeah.
How's it going? This
Yeah, we're actually, we're voting blank in the number.
okay,
It's pretty big.
So, yeah, this far, first of all, I would factor 6 out of that.
Okay, yes. 6x, we had 6x after.
Yeah, not 6x.
Yeah.
Good here?
I think so.
No, that is weird.
So you just, right, each of these 3 things, but each one you take 6. Maybe you're dividing on those 6.
Yeah, I don't know why.
She's right. And now this thing, and now you sort of.
Yeah, right.
Okay. Yeah, this one should be yeah, if you mess up a little something. Doing all right? Yeah, that looks good. Great. Okay? Okay, good, yes. You should factor.
I'm just gonna use this. Okay. Like 6.
I would say 6.
Okay.
And then after you do that, you can actually factor. Okay?
Yeah, that is really good. Oh, that's right.
Yeah, yeah, I would say first factor the 6 out. I think you're being a little premature with that. Right, like 6 in the front and then, I mean, you're right, each of these first.
Okay.
It's good so far. You didn't mess it up yet. I would say divide, factor out 6 from that. Should get something like that. Didn't say what it is. Yeah, this is not fully scrolled up. That's the end part of what I was doing. Yeah. Yes. Yes.
Okay, but.
So you factor, yeah. This is where you absent for the first 12 minutes. In spirit, you know. Yes.
So when I'm here,
Mhm.
can I just take that 6 out?
So that's good, although this should be 2 now.
Oh, great.
Because when you factoring like that, you're really dividing everything by 6. And then that thing that you have now, you want to factor some more by turning it into, if you leave the successor, then this part you turn it into two things.
Oh, okay. Okay, thank you.
That's still good?
Maybe that came from the 6, but this 6 doesn't become really what you're doing for the solutions is setting each of these things equal to 0. So we're taking that as 6 here.
The first 6. Okay.
So you don't get any
So 6
X.
Still good here?
I'm just
Okay.
not sure about what to do.
Yeah, one of those, I think you're plugging in. I would say you plug this numbers into here. I would suggest you factor, you just put that is the same as this, and that's
Oh, right. Okay.
what I put in the box is the factor.
Okay.
And then, yeah, this is.
Okay.
I'll give you a couple more minutes and then we can talk about how to go. How's it going here? This is very good. So I would say some factor. Really, you should parentheses for the 6s. I don't want the 6 to go up. And then you can still factor this. All right, let's talk about them. Some of you realized that if you mess it up at the beginning, it totally screws the whole rest of the thing, unfortunately. So my advice is, I don't know, I guess just don't mess it up. It's hard to avoid screwing it up. Anyway, you should begin by taking the derivative, and you get 6x squared plus 6x minus 12. And then you should factor this as much as possible. So the first thing that occurs to me is to factor 6 out of there. And what's left over is x squared plus x minus 2. And then that thing in the parentheses there can still factor a little bit more. I'm talking about this kind of thing here. When you factor that, you need to choose numbers for here and here so that when their product is -2 and they add to +1. I believe the way to do it is +2 and -1. So this is my factored version of f prime of x. If you don't feel good about this much, I saw a lot of people as I was walking around were just totally stuck on the factoring. That is something for you to work on. I mean, I'd be happy to, I'm not saying that that's a you problem, but it kind of is. I'd be happy to help out, but doing factoring like this is super important in most of what we're going to do for the rest of the semester. So if you don't feel good about that, get yourself good with that. And I would be happy to try and help out with that. Anyway, these are the factors. Now I'm going to find the critical numbers by setting this equal to 0. It says 6, x plus 2, x minus 1 equals 0. Each of those you set equal to 0. Oops. Equals 0. X minus 1 equals 0. Come on. Now this didn't happen in the previous examples. This is weird though. 6 equals 0. What does that mean? I mean 6 does not equal 0. So what I'm looking for in this step are solutions for x. And what that means when you see something like 6 equals 0, there's no x's over here. There's no critical numbers that I get from that part. So you can just kind of ignore that part. The other two parts are where the good stuff is, right? X plus 2 equals 0 means x equals -2. X minus 1 equals 0 means x equals 1. And these are my critical numbers. That other one doesn't give me any critical number. All right, now I'm going to make my chart. -2 and 1 on the chart. And my derivatives, I'm going to plug values in to this formula here, which I will copy down here. Come on. Maybe I'll put it right on the line there. All right, so I'm going to plug in, let's do, for the point on the left, let's do f prime of -3. Plugging into the formula in the box, it's 6 times -3 plus 2 times -3 minus 1. That would be positive, negative, and negative. So this is positive. I hope that's what you got. I hope I didn't mess it up. All right, so positive on the left side. In the middle, I will choose x equals 0. That's my favorite number to plug into things. 6 times 0 plus 2, 0 minus 1. That's positive, positive, and that's a negative. So this is negative. That's going to be decreasing in the middle. And then on the right side, f prime of, I'll choose 2. I get 6, 2 plus 2, and 2 minus 1. And these, each of them are positive. So it's a positive on the right side. And so my final answer is it's increasing and then decreasing and then increasing. So I would say specifically increasing on -infinity to -2 and also 1 to infinity. And it's decreasing on -2 to 1. There you go. I hope that's what you got. I saw this from a lot of people as I was going around. So good job. All right. That's how we do it. Okay, this is, I said the first one that I did was kind of an easy one. This, I would consider this one to be typical for, you know, what you might encounter on the test. So I hope that you feel good about this one. If not, then I hope you will feel good about it within a week, because that's when you gotta do it. All right? Okay, so this was number 19 on the list, increasing, decreasing, parentheses, polynomials. I think that's what it says. Number 20, like I said before, is increasing, decreasing, parentheses, harder. So what can the harder ones look like? Harder ones. These would be when the function is not a polynomial. It is a more complicated thing to take the derivative of. So harder ones could involve, well, I will just say weirder functions. All right? A polynomial is an especially easy function to take the derivative of. You just do the power rule, and then you can factor it, and you do like we just did. But if the function is not a polynomial, you can't just use the power rule, and then it becomes quite a bit more complicated, as you'll see. So weirder functions, and we are going to focus particularly on functions involving fractions and also functions involving exponentials. So I just want to do one example of each of those, and that's fairly representative of what you might encounter on the test for this number 20. So let's try, so I will just reiterate, in these, the critical numbers, this is something I said a few moments ago, but I will say it officially now, are any x with f prime of x equals 0, or f prime of x does not exist. All right, because it's possible for the increasing, decreasing business to, it can flip from a positive to a negative if the derivative is 0, or if the derivative does not exist. So let's just try, I got 2 of these, and then I have one for you to try. That'll probably do us for today, but we might move on to something else. So let's try f of x equals 2x minus 1 over x minus 5. All right? And your job here is the same. Give intervals where it's increasing and decreasing. All right. What's so much harder about this? What's harder immediately is it's much harder to do the derivative of this. I mean, it's not super hard, but you have to use the quotient rule, right? And so the answer that you get is going to be much more complicated than just a simple polynomial that you can factor. But anyway, that's how we got to do it. So to find f prime of x, we must use the quotient rule. And we get, I hope you remember the quotient rule. It is the bottom times the derivative of the top. So that's x minus 5 times the derivative of the top would be 2. And then minus the top times the derivative of the bottom. That's 2x minus 1 times derivative of the bottom is 1, right? And then it's all of that divided by the bottom squared. All right? Now, ordinarily, when I tell you to do the quotient rule, I say you shouldn't simplify the answer unless you have some reason to. This is a case in which you have some reason to now, because now I get this big thing, and now we have to continue the same procedure from before, which is to say, find when the derivative equals 0 to find the critical numbers, and also we're going to find when the derivative does not exist. So we need to set f prime equals 0 and also find when f prime does not exist. So we should simplify this as much as possible, all right? Ordinarily, I'm not into simplifying like just for fun. If all I asked you was to find the derivative of this, then this is the answer. That is the derivative. And usually it's not important to simplify. But in this problem, because we have to do more stuff with this, you better simplify this as much as possible. So what am I going to do to simplify here? I think the only sensible thing to do would be to distribute these multiplications in the top and then try to actually do the subtraction to recombine the terms on the top. So this, I'm just continuing this thing, simplifying. I hope you wrote some parentheses there. If you didn't, if you're a parentheses hater, you may not know what to do at all next, but when you have the parentheses in there, you can tell. You should distribute the 2 first. So it's going to say 2x minus 10 minus, and then I suppose you don't really have to distribute times 1, doesn't do anything, but I should distribute the minus sign here, right? So it's going to be minus 2x, and then minus a minus 1 is a plus 1, right? On the bottom, I have x minus 5, the whole thing squared. You could, if you want to, FOIL that out, but actually you'll see when you're used to doing these problems a little bit, it's not helpful to do the FOIL on the bottom. It's actually better to leave the bottom like that. So I'm going to leave the bottom like that. It's because you want things generally, in a problem like this, you want things to be factored. And this is factored. If you were to multiply it out, then you will have undone that factoring. So leave it like that. All right, what can we do up top? We can actually do these various additions and subtractions. And I think what happens is the 2x's cancel, because I have a 2x and a minus 2x. And then the numbers do not cancel. I have negative 10 plus 1, so I end up with negative 9 on top. X minus 5 squared. And that is as simple as this is going to get. So this is what I'm going to use for the rest of the problem for my derivative. Negative 9 over x minus 5 squared. All right. Simplifying for a reason. I don't like just simplifying for nothing, but here you really want to simplify it. Okay, anyway, what I said before, we need to set f prime equal to 0 and also find when the f prime does not exist. So let's try set this equal to 0 and also say where it does not exist. Actually, the DNE thing is a little easier. So I'm going to do kind of 2 little parts here, the DNE part and the f prime equals 0 part. The DNE part, in a fraction, you are always looking for numbers which make the denominator equal to 0. So for the DNE, what we have to do here is check when the denominator equals 0, right? Can anybody tell me, since it's already sort of factored in the bottom, this is easy to say. What numbers make the denominator 0? Yeah. 5 is the answer, yeah. If you use x equal 5 in the bottom, it makes it 0, and that's the only way the bottom could be 0. So this will be, if you really want to be, fancy about it, you would write down, set the denominator equal to 0, and then solve for x. But since this is already factored in everything, I just get x equal 5. All right, so that's a critical number. And then we also need to check this, f prime equals 0. So for this part, you just set this thing equal to 0, like so. And you try to solve for x now. And in this case, to solve for x, I would, because I have a fraction on one side, I would multiply the denominator on both sides. So multiply both sides by x minus 5 squared. You're doing like a cross multiply kind of thing. It looks like negative 9 equals 0 times x minus 5 squared. All right, I'm trying to clear out the fraction by multiplying the denominator on both sides. But what I see on the right-hand side is now 0 times whatever. It's going to be 0 on the right side, right? So this says negative 9 equals 0. How do you like that? I hope the tour doesn't walk by when I say negative 9 equals 0. This obviously is false. What's your interpretation of that? Yeah, that means in this step, there is no critical number from this part, right? You always have these two parts. You're checking when the derivative does not exist, and then also checking when the derivative equals 0. Apparently, this derivative never equals 0. That's your interpretation here. There is no solution. What that means is f prime is never 0. But anyway, it just means there isn't a critical number from that step. So the only critical number here is x equal 5. All right. Sometimes you get critical numbers from both steps, sometimes from one but not the other, and so on. So x equal 5 is the only critical number. All right. Insofar as this is like a harder version, I would say the hard stuff is over at this point. The rest of it is fairly similar to what we've done before, and that is you make the chart here. In this case, we have only one critical number, so the chart is not very complicated. It just has 5 here, right? This is my same old chart. And then f prime at 5 does not exist. So rather than, in previous examples, I put a little 0 there, this time I'm going to put a little DNE there, because 5, what's interesting about this is that's the x value where the derivative does not exist. But anyway, we proceed as before. We plug a number, some number bigger than 5 and some number smaller than 5. And we were plugging them, remember, into the derivative, which I will find is this. So plugging into that formula, I go f prime of, to the left of 5, let's use 0. You could use 4, but I always like 0. What do you get? Negative 9 up top divided by 0 minus 5 squared. This is negative 9 over 5 squared. Negative 5 squared, I suppose, but that's positive on the bottom, right? Anything squared is positive. So this is a negative divided by a positive, which is a negative. All right? Again, if you have everything factored, you can analyze this entirely in terms of negative times a positive, or negative divided by a positive. And what you're looking for is, if there's an odd number of negatives, then the whole answer is negative. And if there's an even number of negatives, the whole answer is positive. So f prime of 0 is negative. That means I put a big old minus on that side. And then something bigger than 5, I'll choose 6. F prime of 6, this is negative 9 over 6 minus 5 squared. That's a negative over a positive. Remember, anything squared is always positive. So it's a negative over a positive, which is a negative, and I get a minus over here. This is an example where the signs do not alternate. They don't always alternate. All right, and that's basically it. So it's decreasing over there, decreasing over there. So my final answer is decreasing on the interval minus infinity to 5 and 5 to infinity. And I suppose never increasing. There is no interval where this is increasing. that's how it goes. Anybody got thoughts about that one? I got one like this for you all to try. The hardest part of this kind, I think, is just not messing up the derivative. You have to do the derivative properly, which involves the quotient rule, and then simplify properly, which is some opportunity to screw it up. How about let's try that. See what you think. I hope you all remember the quotient rule. How's it going over here? They're walking by, so I've got to look nurturing and insightful. Excellent so far. Don't forget your. Yeah, so it's minus this one did after the minus.
I see. Yeah. So I would make this whole thing 0 or just set it equal to 0?
Those are two separate steps. For the DNA step, we use what makes the denominator 0. So set just the denominator 0. For the other step, which is f prime equals 0, then you set that thing equal to 0. Okay? Okay? Yeah, so you choose something less than -1.
Okay, but it's, you put it into this.
That's, yeah.
I wasn't sure if this was obviously this. I mean, you could
Well,
say that.
yeah, they're equal.
Yeah.
What you choose.
Alright, perfect. So we're on the right track. Yeah.
Yeah, that's right. Yeah. Yes. Yes, we should. So within the quotient rule, this is the bottom.
So why would I have the 5?
Because it's the bottom and this one is, so that 4 should be positive. You good? This is right. Yeah, that's great. So this should be positive. Because this in the quotient rule is the derivative.
that's good.
So this is minus.
Plus,
Yeah, plus 4.
Right, I'm sure. I don't know if it still is in this. You guys are decreasing both times.
Oh, it's a negative 7. This is a
I don't know. How did you get negative? I'll do it in a minute. You can argue about it. All right, let's chat about this one because I have one more type of hard one to do.
You do g of x first, and then times derivative.
Let's begin with the quotient rule, right? So I go the bottom times the derivative of the top is like this, minus the top times the derivative of the bottom is 1 over the bottom squared. Right? Unfortunately, in the quotient rule, you have to put the stuff on the top of this fraction has to be written in the proper order. If you get it backwards, then your answer will turn out to be negative, the negation of what it ought to have been. So I believe this is the right way around. Now we should simplify as much as we can, which involves distributing. So this is going to be 3x plus 3, and then minus. The times 1 doesn't matter, but I should distribute the minus sign. I get minus 3x plus 4 divided by x plus 1 squared. I'm just going to leave the bottom like it is. The 3x's cancel. I get 3 plus 4 up top, which is 7 over x plus 1 squared. This is my derivative. I hope you got that. 7. Okay, that's the derivative. Now we are going to do to find the critical numbers, I have to say when f prime does not exist, and also when f prime equals 0. For the DNE step, you set the denominator equal to 0. X plus 1 squared equals 0. Solving this, I just get negative 1. So this is a critical number. And then for the f prime equals 0 step, I set the whole derivative equal to 0. But this here gives me no solutions because if I tried my best to solve here, I would multiply the denominator over. I get 7 equals 0 times x plus 1 squared. And this just says 7 equals 0, which gives me no solutions from this part. Nothing. All right, so anyway, x equals minus 1 is the only critical number. And then I should be plugging in to my derivative, let's say 0 on the right side and negative 2 on the left side. And my derivative is 7 over x squared plus 1. What? X plus 1 squared, sorry. 7 over x plus 1 squared. So I go f prime of, say, minus 2 is the point on the left. 7 over minus 2 plus 1 squared. This is positive and positive. The bottom is a square, so it's going to be positive no matter what. So this is positive. And then f prime of 0 is 7 over 0 plus 1 squared, which again is positive over positive, which is positive. This is positive. And so I get increasing and increasing for these two intervals. f is increasing on minus infinity to -1 and also -1 to infinity. Never decreasing. That's that. I hope you got something like that. I realize now, as I was walking around, I was a little confused about what the answer was supposed to be. Some people put -7 on the top because he messed with the quotient rule. All right. Excellent. Problem like this, in my opinion, there's a lot of opportunities to make sort of a small mistake which screws the whole thing over. So when it comes to the test, our test questions unfortunately don't really have partial credit. If you really did something that was almost perfect but not quite right, I might still give you the full credit on it. I'm not going to ruin your whole score because of one little thing in a problem like this. All right, great. I did ruin some people's scores on the first test because of one little thing, but I only do that sometimes if it's a fairly easy kind of question that I know you're just going to get right the next time around. I might make you do it again the next time around. This kind of thing, though, you have to put in a lot of work for it. All right, let's try one last type of harder one. We got another 20 minutes or so, which I think will be enough time. How about harder with some exponentials in there? Exponentials in there. Let's just try one. X times e to the -3x. How about that? For the sake of the test, probably I'm going to use e for a problem like this, just because the other kind of exponential function involves a ln a in it, which is a pain to do if you don't have a calculator. So we should remember about exponential functions, the derivative of e to the x. Anybody remember this formula? This should be one of your favorite formulas. It is e to the x, yeah. Speaking of favorite formulas, I hope you all had a good, healthy Pi Day yesterday. I didn't really do anything special for Pi Day. Sometimes life gets in the way, you know what I'm saying? This is the formula that we're going to have to use for this one. Anyway, let's not try to get too upset about it. Let's just try and do all the same stuff. So I'm going to begin by taking the derivative. Now, when I'm taking this derivative, I will have to use the formula in the box because it has a e thing. But there's also this x in the front. So actually, this derivative is a product rule because I have two things there being multiplied together. All right. So I'm going to, when I do the derivative, we need to use the product rule. I hope you remember the product rule. It's the first thing, which is x, times the derivative of the second part. Now the derivative of e to the -3x, I use this formula in the box here. Derivative of e stuff is always just you get the same answer again. But because of the chain rule, you additionally have to multiply times the derivative of what's on the inside. So derivative of e to the -3x is e to the -3x times, this is the chain rule, the derivative of the inside. All right, that's similar to ones that you did on the homework for Tuesday. Anyway, that is the first half of the product rule, right? The first thing times the derivative of the second thing, and now I do plus the second thing, like it is this, times the derivative of the first thing. Derivative of x is just 1. So it's that. So that is, fairly routine, I suppose, product rule involving an exponential function. All right. What's a little tricky is to proceed from here, we need to set that thing equal to 0. And this is a bit complicated. So as usual, I'm going to try to simplify as much as possible. And as written, it looks like actually you can't do too much. It might be helpful. Basically, I have here two things which are added together, right? So I'm going to maybe just sort of clean things up a little bit. I'm going to gather those guys in the front. And then it says plus e to the -3x times 1, right? But you don't have to write the times 1. Anyway, can we simplify this at all? Actually, you can factor this here I have two things added together, and they both involve e to the negative 3x. So the next step should be factor out the e part, which in this case is e to the minus 3x. So I'm going to write that out in the front. And then what's left over from the rest of it? Negative 3x plus 1. It's because here I had negative 3x times the e, and then here I have 1 times the e, right? So when you factor the e out, what remains from each of those, the first one was negative 3x, the second one is just a 1. All right? And this now is as simple as this can get. So this is f prime of x. This is my simplified and factored form. All right. Okay, we proceed as before then. We have to check when this does not equal 0 and also when this does not exist. Actually, the DNE step is not relevant here because there's no denominator to look for. So really, we only need to consider when f prime equals 0. So we go e to the minus 3x times negative 3x plus 1 equals 0. And we're trying to solve for x here. Since this is already factored, it means I can split this into two things. E to the minus 3x equals 0 or negative 3x plus 1 equals 0. The first one there is a little weird, but the second one, at least we can solve for x in something like the usual way. I would add the 3x. So this one I would say 1 equals 3x and then divide by 3. X equals 1/3, right? For the other one, involving the e, how do you solve for x in a situation like this? You might consider using a logarithm here, but actually there's, when you're doing problems like this, they all kind of go in a similar way, and there is a cute slogan about exponential functions that you should know, or you should remember. This is the graph of e to the x. I don't know if you remember. It looks like that. And something to notice is e to the x is always positive and never 0, right? I mean, it's true. If you look at the graph of e to the x, it looks like that, which is always positive and never 0. And what that means is this right here has no solutions because e to any power cannot ever be 0. All right, so this is something that you should remember when doing one of these problems. This part here gives me no solutions. That's because e to whatever power is never 0. And it's always positive. All right. And so my only critical number is this one here, x equals 1/3. And from now on, we can just proceed as usual, making the chart and plugging the numbers in. All right. Let's try it. So I make the chart here. These are my x values. My f prime is 0 right there at 1/3. I need to choose a number less than 1/3 and a number bigger than 1/3 and plug them into the derivative. What do you say for a number less than 1/3? How about 0? That's a good choice. I'm plugging into the derivative, which is somewhere around here, this thing. This is my derivative. All right, plugging into that, I get e to the minus 3 times 0, negative 3 times 0 plus 1. What's that? Is it positive or negative? Well, the second thing here, this part is just 1 plus 1, right? Negative 3 times 0 plus 1. So that's positive. What about e to the negative 3 times 0? You may be tempted to reach for your calculator in this part if you want to know really what is that. But I will refresh your memory about this slogan that I just said a moment ago. E to the x is always positive and never 0. So e to any power is always positive. So this is automatically positive. That's because e to the whatever is always positive. So when you're doing a problem like this, you just have to remember that the exponential function, wherever you see it, is always positive and it's never 0. All right. Anyway, this is positive and positive, which means the answer is positive. So up here, that was on the left side. positive. All right, and then on the right side, I do, what number should I use? Greater than 1/3? 1. Yes, they're showing me the finger, the good one. E to the -3 times 1, -3 times 1 plus 1. Again, e to any power is always positive, and then the other one you have to think through. This thing is -3 plus 1, which is -2. So this part is negative here. And so this one is a negative. So I have an increasing and a decreasing. So that's my answer. It is increasing on the interval -infinity to 1/3, decreasing on the interval 1/3 to infinity. That's how we do it. Do we have time for you all to try one like this? And that will do it for this increasing, decreasing business. Let's try it. I don't know if this is really enough time, but we can give it a good attempt at least. How about f of x equals 2x times e to the 3 minus x? See what you think. See how you feel. You should begin by taking the derivative using the product rule. Yeah, that's
you should begin with the product rule. So the two parts are like this, 2x.
Okay, so it would be 2x times.
Yeah, because the derivative of the three parts is just the same thing.
Yes, sir.
Right.
So you have to do the chain rule next part times the derivative.
Oh, okay.
So it is what you're looking at.
Plus that. Okay, thank you.
Alright.
So I should do the product rule right here. Yeah, this is not clear. So when you take the derivative of this, derivative of d to anything is always the same thing again. Then times the derivative.
Still be e to the 3 minus x.
Yeah, and then separately multiple times the negative 2x. Because that's the chain rule. So today is another two, right?
Yeah, I can give you a piece there. You can just ask me, right, I guess, right?
Just the two part.
Yeah.
Yes, great.
And it was certified.
Yep.
Yeah.
Good here? This looks pretty good. This is the very most part, right? The first here should be the derivative of the inside.
Yeah, you look at that, is it? Yeah.
That's a constant, so this should be good.
Oh, so.
Yeah, negative 2x plus.
Should I factor out factor 2 2e and leave negative x and just do e?
But it's not just x, because you get this part. So, shoot. Like if you just took the e out, the answer would be also taking the 2 out. This is going to be a factor negative, like, again.
And then this is just my solution.
Right, the other part gets you something. Any good here? Yeah, looks good. No, perfect. Alright. It's not. Yeah, you should do the product rules and stuff. First one's 2x. Same thing, and then you also have to multiple times the derivative of the outside.
And the derivative of the answer is just.
inside is 3 minus x. The derivative of 3 minus x is c.
Oh.
Okay? Something, this 3 is not, that comes from the derivative of the inside, which is, this 3 is a constant, so this will go in the derivative. And then this part actually gives you something.
So it's negative.
Negative 1. You good? This is pretty good. Maybe we left it out. That's minus 1.
Oh, okay.
I think, I know I didn't get all the way around, but I think I should go over this now just because we're gonna have to leave in a few minutes. So this, I consider this one to be a hard one, and it's especially hard if you, I mean, in this case you can kind of copy the one that I just did step by step, and it works out very similarly, but it can be a little tricky to remember all the details of how to do one like this. Anyway, we began with the product rule. So it is, the first part is 2x times the derivative of the e part. Derivative of e to any power is the same thing again, and then I multiply times the derivative of the inside. The derivative of 3 minus x, when I take the derivative of that, the 3 goes away, the minus x becomes negative 1. So that's the derivative. This is the first half of this product rule. The first part, like it is, times the derivative of the second part. And then plus the second part, as is, times the derivative of the first part would be just 2. All right. I hope you're with me that far. Next, I'm going to just kind of sanitize a little bit. You can combine some constants in the first term there. It'll say negative 2x e to the minus, no, sorry, e to the 3 minus x, and then plus 2 e to the 3 minus x, like that. That's just shuffling things around a little bit. And now I'm going to factor the e part out of this. Actually, you could also factor 2 out, but it doesn't matter. That will not change much. I'm just going to factor the e part out. So what remains when I remove the e's is negative 2x and then plus 2, like that. I factored the e part out to the front. And what's left over is those 2's and the x, like so. All right. This is my fully simplified f prime of x. You can't get any better than that. I suppose you could factor the 2 also, but that ends up not making a difference really. All right, next I'm going to find the critical numbers by setting this equal to 0. So I go, okay, f prime equals 0. This is what I'm doing now. E to the 3 minus x times negative 2x plus 2 equals 0. This is already factored, so I split it apart into 2 things. E to the 3 minus x equals 0. This gives me no solutions because e to any power can never be 0. The other one gives me something worth discussing. Negative 2x plus 2 equals 0. That one you can solve for x by, I would add the 2x to the other side. 2 equals 2x, x equals 1. Come on now. There you go. All right, so we have just one critical number, and it is x equal 1. I make my chart. My f prime is 0 right there, and now I'm going to plug some value less than 1, some value more than 1 into this derivative here. I'll put it down there. So something less than 1, I'll choose 0. F prime of 0. This becomes e to the 3 minus 0 times negative 2 times 0 plus 2. That's positive because e to any power is always positive. And then the other one you have to actually think through, but the other one equals 2, right? Negative 2 times 0 is 0, and then plus 2 is 2. So this is also positive. So I get a positive for the first interval. And then the other interval, I will choose, my number there is 1, so let's choose 2 for the other one, f prime of 2. I get e to the 3 minus 2 times 2 plus 2. This, again, is always positive because e to any power is positive. And the other one is, if I multiply and add, this is negative 4 plus 2 is negative 2, which is negative. So this is negative over there. So my final answer is increasing on minus infinity to 1, decreasing on 1 to infinity. I hope you got something like that, although I know I didn't give us all that much time. I could have given you 4 more minutes. I think we'll leave it at that though. Please let me know